So this is exponential growth. And what do you think it is if I change this to a 1/2? Well, it's not exponential growth anymore. What do you think it is? Just guess. Somebody's probably thinking it. All right, exponential, not growth. Decay is actually the word for it. It goes like that. Now, it slows down. It's kind of like this. Let's say you had $1 million, and then you cut it in half. Now you have $500,000, and then you cut it in half. You have $250,000, and then you cut it in half. And now you got $125,000, and then you cut it in half, and you cut it in half, and cut it in half. Will you ever get to zero? No, if you just keep cutting it in half, you will never get to zero. So there is an asymptote line on both kinds of graphs right there. And I want to remind you, that's the x-axis, so that line is y equals 0. This is a lot like what you had on your last test. There was asymptotes there too. I know it's been a long weekend, and so you probably even forgot what was on your last test. I'm going to go off to the side for a second. This is what's on your next test. It's called exponential growth or decay. It's got an asymptote, always along that way. Sometimes we move it up or down, but that's where it starts. Okay, do you remember the ones on the last test? They had asymptotes here, and there would be a point here, and you just had to know how asymptotes work, and it gets closer and closer and never touches. Do you remember those? All right, it's like this, except there's only one asymptote. The new graphs have only one asymptote like this, and if they're exponential growth, they look like this, because it's growing, it's getting bigger and bigger. All right, would you please copy this one down? And this one's going to be y equals 3 to the x. Now there's two ways that teachers teach this. I want to warn you, sometimes the key does it in a way that you're going to be like, what are they doing? I don't understand the key. It's because sometimes teachers will do this by making the kids memorize 3 of the points on this line and then making them move those points left or right or up or down to get their final answer. It's especially hard if you stretch it. Because if you make the kids memorize this, but then you throw in a negative here and then a +8 there, the kids have to know how to flip the points the correct way. The kids have to know where to move the points to, and I think it's so much harder. I'm going to show you a way that does not make you memorize where the points are. And it just makes you stick numbers into the equation. So let's do that. Everybody make an XY chart like this. We're going to stick in numbers for x, and we get to pick any number we want. So you want, here, listen to this, because this will always work. You want to make your numbers come out small. Like, obviously, you could put in any number. Do you really want to do 3 to the 10th? It's going to be insanely big. So try to make the answer come out really small. Like if I put in 0, that'll come out small. I put in 0. What is 3 to the 0? 1. How about if I put in a 1? That still stays pretty small, right? I put in a 1 and I get 3 to the 1, which is 3. And if I put in a 2, 3 squared, 9. Cool. I didn't have to memorize any points. I can just put in any numbers I want and see what comes out. That's all there is to it. All right. So what happens, though, if it was a 1/2? Then it's going to be way harder. No, it's really not. Everybody write this one. 1/2 to the x. Make an XY chart. Copy this. I can't make you do anything at home, but I can make you write these things down in class. Why? Because it'll make it stick in your memory. Otherwise, you're only going to remember 10% of what I tell you. And I talk fast, so probably only like 5%. But if you write it down, it'll stick way better. I said you could put in any numbers you want for x, but you should try to keep it small. What's a really easy one? Ooh, I agree that -1 is actually a really easy one. I can tell somebody did the homework this weekend. There was homework this weekend. I even sent out a reminder. And you were supposed to use exactly that. And yeah, you would have learned this already this weekend. So you put in a -1. Why is that smart? Because a -1 power flips this over, and 1/2 flips over and becomes 2/1, which is just 2. -1 is actually the easiest thing on a fraction because it just flips it. All right, what's another easy thing? Besides -1, what else can we put in here? 0. I agree, because anything to the 0 power is 1. 0, 1. And one more thing that's pretty easy to do is to put in, what's one more thing I could put in here? 1, I agree. I heard somebody say 1. You're right. If I put in a 1, 1/2 to the 1 is 1/2. And it's not that hard to graph 1/2. It's right between 0 and 1. So if you had graph paper, you would just go over 0, up 1, over, that one's at -1, up 2, and then over 1 and up 1/2. That's like here. And then you remember how I said there's always an asymptote right there unless it's been moved? It hasn't been moved. How do you tell if it's been moved? Is there anything outside of it? The thing on the outside would make it move. Because see, if I put like a +5 here, the whole thing would move up 5, and then the asymptote would move up 5 also. But there's nothing on the outside there. So it didn't move. So it's at y = 0. In a way, you could think of it as there's a +0 on the outside. Can't argue that you could put +0 out there, right? So y = 0 is the asymptote. It's whatever's on the outside. Our asymptote is an outsider. It's whatever's on the outside. If there's nothing on the outside, the asymptote's 0. If there's like a 5 on the outside, the asymptote's 5. All right, I think you're starting to get this. So here's 2 questions we could ask you. Don't even write this down, just listen. Which way did this move? Don't write it down. Just think, which way did this move? That 5 on the outside there, Poppy, do you know which way it moves? Because of that?
Well, I can't remember if it flips or not, but I don't.
That's a fair question. It does flip. You want to do that one? I'm fine with that. That flip.
So it's technically a positive because it flips.
All right, so it flips. Do you remember the math word for flip?
Vertical reflection.
Ooh, very good. That is exactly what I was looking for people to have in their head. Vertical reflection. How about that? Down 5. That's all you have to know on some problems, is which way did it move? Wasn't there a problem just like this on our last test? Yeah, there was. It was just a fraction function before. Like it would have looked like this. Y = 1 over x and then -5. And you would have had to know, oh, it moved down 5. Because that's on the outside. It was just fraction functions on our last test. I know it was a couple days ago, but literally on Thursday. That test. All right. And if there was a negative, it was on the outside, that was a vertical reflection. It's the same thing. Vertical reflection, down 5. All right. But what if you had to graph something like this? Well, everybody write this down. Y = do write this one down, please. 2 to the x minus 3 plus 5. That is as hard as we would ever give you on a test. And we're only about 10 minutes in. And I think you can do it if you choose x's wisely. Remember, you're trying to make the answer small. As you're putting in an x, try to make the answer small. So, like, what's a really nice x number? Say it. 0 works, but it's going to be a pain because 2 to the -3rd is not fun. So I don't like 0. Now, if you mean I want to make this whole thing 0, that'd be smart. But then what would x have to be? 3. 3 would be a good call because it'll make that power be 0. If that's what you meant, then that's exactly right. 3 is a smart thing to put in. Everybody's put in a 3, figure out what you get. Now, some people forgot what to the 0 power means. To the 0 power is 1. Then you add the 5, then you get 6. Who had 3 comma 6? Raise your hand if you had that already. All right. Then, what else could I put in? 3 worked. So hint, if 3 worked pretty good, something near 3 is also going to work. Yes?
2.
2 is a good call. Now, a lot of kids will avoid that because they're like, I don't want to have negative powers. But it's really not that bad. 2 to the negative 1. Negative 1 powers flip over the 2. Isn't 2 like 2 over 1? When you flip it over, it becomes a half. But then I got to add 5. It's just 5.5. So we put in a 2 right here. And 2 to the negative 1 is the flip of 2, which is 1/2 plus 5, which is 5.5. You can totally do that on a test. We are going to have decimals on the test. And when you graph it, you just go between 5 and 6 and put it on. Okay. And then last but not least, I think if 2 and 3 work, well, 1 could work, but I think 4 would work way better. Just because I tried it in my head quick. I'm going to put in a 4 here. 4 minus 3 means to the power of 1. 2 to the power of 1 is 2. 2 plus 5 is 7. 4, 7. Does anybody remember, without me reminding you, what the asymptote would be? Yes, but what about 5? Where is it? There's a lot of 5s on the graph. Up 5. So the asymptote would be up 5, a.k.a. y equals 5. Yep. I don't expect you to be an expert, but I think I've given you enough now that you could actually do this. Let's find out. Here is a good typical problem on your next test. 3 to the x minus 1 plus 2. Make an xy chart. Find 3 points and the asymptote. Find 3 points that will be on the graph and the asymptote. I don't even need you to graph them because you don't have graph paper right now. Just find me 3 legit points and where the asymptote will go. If you're not doing this, why are you even in my room? Try this. This is the key problem. Don't expect you to be perfect. Expect you to try. You know you're not using it, that self not going to be there. Sophia, give me a number you stuck in. 0. What does that give you? It'll work. Don't freak out because it's a fraction. Nope. It'd be 3 to the negative 1, which is the flip of 3. 1/3. All right. I know. You might have wanted to pull out and go, I don't want to actually put in 0. And you don't have to. But if I have a 1/3 and then I add 2 to it, it's going to be 2 and 1/3, or 2.3 repeating. I saw some people had that on their chart. So it's legit. You could do it. But I know you wanted to change it from 0 because you realized it was going to be hard. So what would be something that would be easier than that? 1. Because if you put in 1, 1 minus 1 is 0, and anything to the 0 power makes this whole thing 1. Plus 2, 3. Osano, give me another thing you can put in besides 0 and 1 and hint. You might as well just keep it close to those two because they worked. If you put in negative 1 for where the x is, I think it's going to be harder than you think. Now it's going to be negative 1 minus 1 makes negative 2. 3 to the negative 2 is not easy, but you can do it. Do you know what it is? Or do you want to change what you put in?
I can do 2.
All right, I think 2 would have been better. 3 to the 2 minus 1. Oh, that's easy. 2 minus 1 is 1. 3 to the 1 is 3. Plus 2 is 5. 2, 5. And then the last thing is, where's the asymptote? Up 2, but you should say y equals 2. Because if they ask you to write it, you have to write this. Even though you might know the asymptote's going to move up 2, that's true. The name of it is y equals 2. That's the asymptote. Now, I didn't ask you to graph it, but if you did, it'd be an exponential growth, and I'll just graph it for you. It'll look like this. Over 1 and up 3 is right there. Over 2 and up 5 is like right there. And over 0 and up 2 and 1/3 is like right there. And look, if I just connect them, exponential growth. Yay. That's what they look like. I just graphed the 3 points that you guys just figured out. One more that would have worked pretty good is if I put in a 3. I know some of you did that. 3 minus 1 is 2. That means 3 to the power of 2, which is 9, plus 2 is 11. And if you want to go just off the graph, it's okay. So like if this was a test and then you had a dot up here, it was just off the graph, you just have to label it. And say like, I know it's off the graph, but that's 3, 11. If you go off the graph, I'll count it as a legit point if you label it. Anything over 10 is going to go off the graph, so you just have to, put a little like, that's what that is out there. Okay? Yay, that went way faster than last hour. So that's the new stuff for today, is graphing exponentials. I'm going to pause while I hand out the worksheet. Now that I got the worksheet handed out, here is the first problem on it. Number 1. It says f of x, which I like to say is y, and I'm right above the graph, by the way. Above the graph, do you see that? 2 to the x plus 3. Now you have to have an xy chart. All they're showing you on that like little picture, they draw one for you and they say this is the parent and it looks like this. But ours is going to be different. Ours is going to be moved up 3. All right, so anyway, on our xy chart, I just taught you to stick points in. I'm going to stick in the point 1 because that's easy. Anything to the 1 is just itself. So that's 2 plus 3 is 5. But I want you to not be afraid of -1. Everybody take a second, put in -1. You don't have to, but it does come in really handy on the fraction ones. To the -1 power means that's 1/2. -1 power flips it over. That's one of the things you were supposed to learn this weekend if you did this weekend's homework. I know some of you were like, I'm not doing homework on the weekend. Okay, fine. That's your life. But it was worth twice as much as a normal assignment. I would still do it if I were you. There was homework on the weekend. I sent out an update about it. I told you about it in class. I know most of those went over your head. But if you didn't do the homework, that's where you would have learned this. All right. So anyway, go back and do it. You can still turn it in for full credit if you haven't done it yet. So that becomes a half. Half plus 3 is 3.5. Do you have to use -1? No. You could use 2. Anybody in here can do that. 2 to the 2 is 4. Plus 3 is 7. So I put in a 2, and I got a 7. The problem with just using 1, 2, and 3 is that it's going to go off the graph. But didn't you say we could go off the graph? Yes, I did. You can go off the graph if you label it. So 2 to the 3rd is 2 times 2 times 2, which is not 6. What's 2 to the 3rd? 8 plus 3, 11. 3, 11. That one, if you want to use it, is fine. But you got to label what it is because it went off the graph, so nobody's going to know for sure what it is unless you label it. These are the 3 that most people would have done. I'm just showing you it's not that scary if you know how to do a -1 power because it just flips it over. All right. You have a ton of time, so you have to do the entire worksheet. It's not that hard. There's 6 questions. You're probably going to be done with this well before the end of the hour. All right. So, wait a minute. What's the asymptote again? Isn't those important? Yeah, without the asymptote, you get every problem wrong. The asymptote's that. Y equals 3. So your asymptote on this graph is going to be moved up 3. It's like this. goes through at 3, and then your whole graph will look something like that. All right. If you get stuck, I would love for you to ask me for help. And that's all I got for you for today.